Alright, hello everyone, welcome to this video. So in this video I will be showing you how to train a custom object detector using YOLOv4-tiny and Darknet. So if you've watched my previous video, I showed you how to train a custom YOLOv4 detector. So in this, for YOLOv4-tiny, the process is mostly the same with very few changes. Apart from the pre-trained weights file and the CFG file, rest all the steps are the same. And I've also made one small change. Instead of cloning the Darknet Git repository in the Google Drive as I did for the YOLOv4 video, I'll be cloning the Darknet Git repository and all these files on the Colab VM. I'll be copying these files, obj.zip, custom CFG file, data and names files, and this processed PyScript all onto the Colab VM over here. So this will make the process much faster. So also one thing to keep in mind, YOLOv4-tiny takes a lot less time as compared to YOLOv4. When I trained for YOLOv4 mask detector, I trained for 1500 images and I have two classes, so that was 6000 iterations. It took many hours, but for YOLOv4-tiny, for the same number of images and classes, it took me around 45 minutes. So it's better to know about YOLOv4-tiny training on Google Colab. If you have YOLOv4 installed on your system, then you can go for YOLOv4, as it is more accurate for images and videos. But when it comes to real-time object detection, YOLOv4-tiny is a better option because of its much faster inference time. So I'll be talking about that later on. For now, let's just jump right into the training process. Let's get started. So I'll be sharing a link for this Colab file in the description. You can also check out my Medium article. I'll be giving the link for this Colab file over there as well. And I'll also be giving the link for my GitHub for my custom files for YOLOv4-tiny training. So you can find these links on my Medium article. Okay, so let's begin. Click on the link for my Colab file. Go to File. Click Save a Copy in Drive. This will open up a copy on your browser. Now click on Connect. Once we are connected to the VM, click on Runtime. Change Runtime type. Choose Hardware Accelerator as GPU and save. Okay, now we are good to go. So as in the previous tutorial for YOLOv4, for this I've also devised 12 steps. As I mentioned earlier, they're mostly the same, very few changes. So let's begin by running the first cell. Let us clone Darknet Git repository. This will clone this repository on our Colab VM. You can see the Darknet over here. It is cloned in the content folder of the Colab VM. Next, step 2, create YOLOv4-tiny in training folders in your drive. Create a folder named YOLOv4-tiny. Next, create another folder named training inside the YOLOv4-tiny folder. Let's do that. YOLOv4-tiny. Inside that, create another folder named training. Training folder is where we will save our weights during the training process. Okay, for the next step, this is the main step that we need to be very careful with. We have to upload these four. For the first, we need our labeled custom dataset. So I already have my dataset file over here. I have both the images and its corresponding YOLO format text files over here in the same folder. Now just create zip file and upload this on your drive in your YOLOv4-tiny folder. Click on new file upload, my desktop, obj.zip. Okay, so that's done. Okay, about your label dataset, you can read my Medium article regarding collecting datasets and the labeling process. So okay, one thing that I have to mention, just keep in mind that all your images, they have to be in JPG format. Okay, as you can read over here, other formats such as .png or even .jpg in capitals, they won't be recognized. So make sure all your images have this .jpg format, because the process.py script only has .jpg, this one mentioned in it. Okay, move on to the next step, and this is the most important step for this. The rest of the process is fairly the same as the previous one, but for this YOLOv4-tiny, we have a separate custom CFG file, so we can download it from Darknet CFG directory over here and go down below. YOLOv4-tiny custom.cfg, this is the file that we want. Download it, and now we have to make these following changes in it. Okay, so open the CFG file, make these changes. Change line batch to 64, this is already 64, line subdivisions to 16, change line maximum batches to 6000. It is actually number of classes into 2000, but since I have two classes, the minimum should be 6000. I'll write 6000 over here, and the next two lines for line steps is 80% and 90% of maximum batches, so it will be 4800 and 5400. Okay, for the next step, change network size, width and height to 416. That is already set. And next, change line classes from 80 to your number of object classes in each of the two YOLO layers. If you remember, in the previous YOLOv4 training tutorial, for that YOLOv4 custom CFG file, we had 3 YOLO layers, but in this YOLOv4-tiny, we only have 2 YOLO layers. So you have to do this step just 2 times. And also the next step, that is change filters from 255 to your number of filters. You can calculate your filters using this formula, number of classes plus 5 into 3. Since I have 2 classes, that is 2 plus 5 into 3 is 21. So you have to do both these steps 2 times. Change filters in the 2 convolutional before each YOLO layer. So let's do these steps. At the bottom, change the classes to 2 and filters just above it in the convolutional to 21, and then find the next YOLO layer and do the same over here as well, 21, and that is it. Save it. Now again we can make a few other changes in this CFG file to make our model even better, like change the saturation, exposure, or hue, or the learning rate. but if you're starting out as a beginner, these changes are enough. So just do that, and we have our custom CFG file ready. For the next step, create your obj.data and obj.names files and upload them to your drive. Okay, this is how your obj.data file should look like. For the first line, it gives us the number of our classes. The next two lines give the path to the train.txt and the test.txt files. I'll explain what these two files do later on. And then the next line give the path to obj.names file, which has the names of all the classes written in it, as you can see over here. And lastly, backup is the part where we'll save our weights during the training process. I've written YOLOv4-tiny over here just so we can differentiate. Of course, you can give any path that you like. So create them and upload them. And the last step, upload the process.py script file to the YOLOv4-tiny folder on your drive. Okay, so this process.py script, this creates the train.txt and test.txt files I was talking about earlier, these two, and where the train.txt file has paths to 90% of the images and test.txt file has paths to 10% of the images. So I have all these files already on my desktop over here. I'll simply upload all these files from over there. Okay, so these have been uploaded. Next, mount drive and link your folder. Choose your account, allow, copy this, press enter. Okay, what this line does is it creates a symbolic link, so that now the path content g drive my drive is equal to /my drive. You don't have to type this every time, you can just use this, it makes it easier. And the next line then list the contents in the YOLOv4-tiny folder. So okay, it has been done, the drive has been mounted, and we can see the contents in the YOLOv4-tiny folder, the ones that we just uploaded in the previous step. And now after this, you can simply click on runtime and run all. It will run all these steps for you and then stop after training your model. But since I have to explain all these steps, I'll run them individually. So for the next step, make changes in the makefile to enable OpenCV and GPU. Also set CUDNN, CUDNN half, and NIBSO to 1. Just run this. This will change the directory to content Darknet, and then set all these to 1. And for the next step, run make command to build Darknet. This can take a few minutes, so just be patient. Okay, so we're done. This took about around a couple of minutes. So okay, let's head on to the next step. And then next step, we'll copy all the files from our drive, these 5 files, onto the Darknet directory on the Colab VM, because it will be much faster, because running all these steps from your drive takes more time and compared to Colab VM. Since YOLOv4-tiny takes a lot less time, as I mentioned earlier, you can just simply copy this on the Colab VM and train it. It will take hardly an hour if you have like 6,000 iterations. If you have more number of classes, it might take a bit longer, but it will definitely be lesser than what YOLOv4 takes. So just run the steps This step is just to clean the CFG and data folders, as they have a lot of files. Just to make it cleaner, just make sure you don't delete this labels folder, as this has all the labels files required to make labels during object detection. So just run this, you'll be fine. Okay, next step, copy the datasets and its contents so that they are now in the Darknet folder. Copy and unzip. Run this. This will copy this obj.zip over here and unzip the contents in the data folder in obj. So we have the images and the text files over here. Okay, for the next step, copy the custom CFG file to the CFG folder. We have it over here now. Just check this to confirm all the changes that we made earlier. Batch 16, weight size fine, maximum batches and steps are fine, and the classes and the filters over here in both the YOLO layers are fine. That's it. Now similarly, copy the obj.names and obj.data files to the data folder. We have these files over here. Check this again. This is fine. And obj.names, yes, this is also fine. And lastly, copy the process.py script file. This will be copied in the Darknet root folder. We have it over here. Now the 8th step, run the process.py script to create the train.txt file and test.txt file and list the contents to see if they have been created. We have these files over here. Go to data folder and check these just to make sure that everything worked out correctly. So I had 1510 images, so the 90% for that will be 1359. So this is fine. So as I was mentioning earlier, if you have PNG or capital JPG format image files, they won't show up here. So you'll have a few missing files in that case. So just verify the test.txt file as well. This will have 151 files. Okay, that is 10%. This is also perfect. Let's head on to the next step. Download the pre-trained YOLOv4-tiny weights file. So YOLOv4-tiny also has separate pre-trained weights file, which is trained only up to 29 conditional layers. So use this link to download it. This will download this onto the Colab VM where we are right now. Our current directory is this Darknet on the Colab VM's content folder. Now for training, we just have to run this step. Darknet detector train path to your obj.data file and your custom CFG file, and lastly our pre-trained weights file, which we just downloaded in the previous step 9. So this MAP represents mean average precision, which just helps us to determine which weights file gives us the best result. I'll talk about that later. Right now let's run this. Okay, suppose we get disconnected. Yes, YOLOv4-tiny will take a lot less time and this will be done pretty quickly, but in case you get disconnected or lose your session for some reason, let me reset the runtime. So I had run this up till iteration number 175. So what this Darknet command does is it saves the weights file, trained weights file, every 100 iterations. I've mentioned it over here as well as on my Medium post. So we'll have, since we are at step 175, we'll have this weights file saved at least one time as YOLOv4-tiny custom underscore last dot weights. So if we have to train again, we don't have to start training from scratch again. We can simply train from where we left off using this command. So let's reconnect again. As I mentioned earlier, now since we've uploaded all the files that we needed and we created all these folders, we uploaded all these files, and we made all these changes. So all we have to do is click on runtime, run all. This will run all these steps for us. All you have to do is just mount the drive. So it has cloned the Darknet repository again in the content folder. Now all you have to do is just mount the drive as we did before. Allow, copy, enter. Okay, it's done. Now you see this will run all these steps for you. Again, this might take a couple of minutes. Okay, so that's done. Now it has automatically run all these steps and it will start the training process for you and then stop after this. But since we already have a saved file, we can stop this and run the next command to restart our training from where we left off using this last weights. So the command is the same as the previous one, except this he has given a path to this last saved weights file. Okay, so just run this and we'll see this will start training from iteration number 100. Yes, okay. Okay, so I'll pause this and come back after all the 6,000 iterations have been done. Okay, so once the training is over, after 6,000 iterations, my average loss reached around 0.16. So that's good. For a good detector model, it should be somewhere between 0.05 and 0.3. So this is okay. And we can see the MAP at 0.5 is around 92%. So okay, let's move on to the next step. Now for the next step, to check performance, define your helper function IamShow. Now this IamShow chart.png step, this only works if your training does not get interrupted. Since YOLOv4-tiny is really quick, it only took around 45 minutes when I trained it. So I will have the chart.png file, it will work. Let's run it. Okay, so this has successfully loaded the chart.png file. So as you can see, this has loss on its y-axis and iteration numbers on its x-axis. So we can see in this the MAP reached around 97% at around iteration number 2600 or 2700. So yeah, this is how we can check where the MAP is the highest. And now for the next step, to check MAP, we can individually check MAP for each weights file. This is the command that we have to use. Detector MAP obj.data file, a CFG file, the weights file that we want to check the MAP for. So suppose I want to check it for weights file number iteration number 3000. Okay, go over to our training folder on a drive. So this is how the weights are saved after the training process is over. So as I mentioned earlier, it saves weights every 100 iterations as custom underscore last weights. And then it saves weights every 1000 iterations So up till 6000 iteration, that was my maximum batches that I had given, and then it saves the best weights and final weights. If you want, you can check the MAP for each weights file individually using this command. Okay, as you can see, the MAP at 0.5 for this is around 94%. So this is okay. Let's check it for best weights file. Okay, for best weights file it has around 96% and 96.5 to be exact. That's really good. Okay, now let's move on to the final step, the last step of our training, this YOLOv4-tiny detector. So the last step is to test your custom object detector. For that, we'll first have to make changes to our custom config file over here. So we have to change this batch from 64 to 1 and subdivisions from 16 back to 1. If you go over to your custom file, you can see for testing we already have batches 1 and 1. These have been commented, and for training we have 64 and 16 that we set earlier. So you can just comment these and uncomment these over here, or if you don't want to do that, you can simply just run this command. That will do it for you. It will change these lines to 1. So okay, it's done. Now we can run detector on an image. Use this command, run Darknet detector test part2 obj.data, part2 custom CFG file, part to the weights file that we want to use. I'll use the best weights file, and then part to the image file that we want to run detection on. This threshold, this sets the minimum accuracy required for object detection. 0.3, that is 30%. You can set it to whatever you want, 70% or 80%, whatever minimum accuracy you require for your object to be detected. Just run this. I have my image inside this folder, mask test images, and I have my videos that I want to test in this folder. So let's see what the result was. Okay, as you can see, it has detected all these masks. This one with 69% accuracy, 85%, 66, 84, and 56 at the back for Mona Lisa. If you've seen my previous video for YOLOv4, you will see that all these were detected with 99% accuracy. So as I mentioned earlier in this video, YOLOv4 works better for images and videos because of its higher accuracy, but YOLOv4-tiny works better for real-time object detection because of its faster inference time. So in a real-world scenario, it would be better to have YOLOv4-tiny. So okay, let's move on to the next step. Run detector on a webcam image. Run this. This is a simple snippet code from Google Colab for camera capture, and except the last 2 lines. Now the last 2 lines are same as the previous command. Okay, now we have this. Click on capture. Let's see the result. Yes, as you can see, this has detected my mask with 96% accuracy, so it's working fine. Let's move on to the next step. Run detector on a video. Again, the command is similar. Darknet detector, instead of test, write demo for video. Data part2 obj data, custom CFG, your weights file, part to your video, and you can give your threshold here as well if you want. Just write -thresh and then 0.3 or 0.4, whatever you want to set your threshold to, and then finally the location where you want to save your output file. I'll be saving it in the same folder with this name, result.avi, and mention this don't show so that it doesn't run the video on Colab. You can run that on your system, but not on Google Colab. Just run this command. It will run object detection on the video that we had. Let me show you the video. Okay, it is already running object detection. This might take a while depending on the length of the video, so you can come back to this later. In the meantime, I'll show you the video that we're working with. This is the video we're working with. Okay, let's check it out. Okay, so as you can see, the output result for this is good. It's not as good as the YOLOv4 output, but still it gives a pretty good result. So that's done. Move on to the last and final step of this tutorial. That is run detector on a live webcam. So for this you can use this code. I have adjusted this for my YOLOv4-tiny train weights config in obj.data files over here. So okay, just run this code, go down below. Okay, as you can see, this is detecting my mask right now, and let me remove my mask. Yes, as you can see, okay, this is working fine. Let me put my mask back on. This is also working perfectly. Okay, let's stop this. Okay, so this is how we train a custom YOLOv4-tiny detector on Google Colab. So I've given a link for my GitHub for the custom YOLOv4-tiny files on this Colab notebook, as well as on my Medium article. I'll be giving all these links in the description, so go and check them out. Okay, that's it for this video, how to train your custom YOLOv4-tiny detector. If you've enjoyed this video, please click on the like button and make sure to subscribe to my channel. And okay, I'll see you in the next one.